This Motion Monday, using an HMI to communicate with a drive. In simple applications, you may wish to directly connect the Copley Drive with an HMI. This can easily be done and can result in a very simple controls architecture when complete. Let's start by configuring the Exor HMI side of communications. The first step in this process is to place the HMI in configuration mode. For this HMI, we press and hold 3 buttons while the unit powers up. Next, we connect our communications cable to the 15-pin port on the HMI. Then connect the opposite side to the USB to RS-232 adapter. Now we create a new project and name it. Then we get the panel's resources and copy them to our project. Next, we configure the controller. We select the Copley protocol, choose Setup, choose COM, and configure as shown. For reference, the panel setup is as follows. Most of these variables will not affect our communications. However, if you are having difficulties, this will show what settings worked here. Now, let's add a simple variable to monitor, encoder position. We will add some text to label the variable. Then, we will add a display for the value. Then, we will select actual motor position as the value to display. Our configuration on the HMI side is now complete. So, we download the file to the HMI. Next, we would like to verify communications from the HMI. To do this, we will use Hyperterminal and form a connection to the HMI. I will open a 9600 baud connection that I have already configured, and we can immediately see the HMI communication. Recall that the position we were monitoring is at register 0x32. The following are the Hyperterminal settings used for this connection. At this point, we have set up and confirmed communications on the HMI side. We will now disconnect from the HMI and connect to the drive with our USB to RS-232 adapter and the Copley communications cable. Cycling power to the drive ensures that we are ready to communicate at 9600 baud. Just as before, we will use Hyperterminal at 9600 baud to ensure that we are communicating properly. Once we are connected, we will ask for the value of the register 0, and then the value of the motor position, just as the HMI would. As we force the motor out of position, we can see the value change slightly. We now know the drive side of the communications is working. Now, we remove the Copley communications cable from the USB to RS-232 adapter, and we remove the HMI communications cable we were using up to this point. We then replace our previous HMI cable with a slightly different one. The new cable is through instead of the previous crossover cable. This is done because we are connecting directly to the Copley communications cable used to set up the drive, which itself is already a crossover cable. Finally, we can now see the motor position value change as we force the motor to move. I hope you found this useful for your application, and thanks for watching.